Okay, this is calculus, math, calculus 1, limits and continuity. I haven't recorded math in a long, long time. So this is the first time I'm gonna record grade 12 math on my channel. This is calculus. This is where, math finally starts to math, if that makes sense. Okay, so I'm gonna go question by question. I'm gonna explain as I go because I haven't recorded any CA videos. But yeah, let's start. The diagram below shows the graph of a function f defined for x greater than 1. So this is a graph. When we say it's defined for x greater than or equal to 1, that means it starts at 1. You see over here it starts at 1 and goes and continues. Okay, consider the function the function h, defined over the set of real numbers, and h of x is this is what we call, don't get confused. This is what we call a piecewise function. Piecewise function basically is, they put this weird bracket over here. They say for x between 0 and 4, the function is the line to x, and for x after 4, the function is x squared plus 2. Okay, so that means from 0 to 4, it would be the straight line to x, and then from 4 onwards, it would be the function x squared plus 2. So it would look like, how would it look? It would look like this, kind of like this. Okay, so over here at 4. So this is what we call a piecewise function, where it kind of switches. Okay, so the piecewise functions can either be what? Continuous and discontinuous. Okay, or uncontinuous, something like that. I forgot the word. Okay, but basically continuous means the graph looks like this. It continues. So let's say it stops, let's say at 1 it stops. That means it will be continuous if the graph continues. But over here, as you can see at x equals 4 in the example I gave you, it's not continuous. You see how there's like a gap? It kind of like jumped. So this is what we call discontinuous. Okay, anyways, so they're telling us that what would be the value of k over here. So they gave us the piecewise function. Before 1, it's the function k minus 12x, and then after 1, it's a function f of x. Over here, it's drawn. Okay, so they're telling us it's continuous at x equals 1. What does that mean, continuous? That means, I don't know, there's some graph, but continuous means that at x equals 1, it has the same point. Okay, it continues. Okay, so over here at x equals 1, what's the value of my y value? It's 8. Okay, and we know that since it's continuous, it satisfies both equations. Okay, so that's how you're gonna solve this. If you ever see continuous, that means it satisfies both equations at that point. Okay, so over here, since it's 8, that means it satisfies k minus 12x. Okay, so 8 is equal to k minus 12x. Okay, and how much is my x value right now? We're treating it at x equals 1, right? That's why I used 8, by the way. So 8 is equal to k minus 12, so that means k is equal to 20. So all you have to do is just check the point they want at x equals 1, look at that y value and see that it satisfies. You should check and no. You should plug it in such that it satisfies the other equation. That's it. It's not that hard. Question 2. The sandwich theorem. Okay. The sandwich theorem basically says if you have a function f such that it's in between two other functions, okay, and well, let me see this. Limit as x approaches 7 of g of x. Okay, yeah, sorry. For the sandwich theorem says if there's a function, any function, f of x, such that f of x is in between two functions, h of x and g of x, that means the limit, and they said that the limit of any function over here, I don't know, h of x approaches 4 is equal to 5, that means the limit of f of x approaches 4 will also be 5. Okay, this is a rule. You can think of it like this. Okay, and also I didn't explain what the limit is, and I'm solving questions with limits because it's in 1.1. Basically, a limit is if you have any graph, okay, and you can see that maybe there's an asymptote. The easiest examples are the ones for asymptotes. Let's say I have 1 over x plus 2. Okay, the asymptote for this, you guys know there will be a vertical asymptote at x is equal to negative 2, right? So over here, you can say that as x, the graph will look like this, okay, like this, okay? You're going to say as x approaches negative 2, look at how much the y approaches. Y approaches negative infinity. So we can write this as what we call a limit. A limit, as the word limit means, basically means as you reach the limit, The limit in this case would be negative 2 because you're not allowed to cross it, but as you're getting close to it. So the way you write it would be limit as x approaches negative 2 equals negative infinity. Okay, so this is how This is how you kind of write it. So here I should have said x, not f of x. I don't know why I wrote that. Anyways, so this is the sandwich theorem. If a function lies in between two functions, that means the limit of this function as it approaches a certain x value will be equal to the limit of this function as it approaches that certain x value. So over here, they told us f of x lies in between 2x and 3g of x minus 1. And they told us that the limit as x approaches 7 of g of x is equal to 5. Okay? طيب, نحن what did they give us here? They gave us 3g of x minus 1. So some people over here, they're gonna write down 5. Oh, that's definitely wrong. Why? Because they gave you 3g of x minus 1. So what do you have to do? As it suggests, 3 times 5 minus 1, which is 14. Why? طيب, نحن they told us that the limit as x approaches 7 of g of x is 5. Now we want the one for f of x. We know that f of x, since it's in between, it's going to follow the one for 3g of x minus 1. So just so I can write it. So the limit for f of x would be equal to the limit of 3g of x minus 1. But they didn't give us 3g of x minus 1. Right? They gave us g of x. Okay, they said that the limit as x approaches 7 for g of x is equal to 5. So we need to manipulate it to make it 3g of x minus 1. So what do? The same thing. You know how you're multiplying here? It's the same thing as multiplying by the limit. Okay, so the limit of 3g of x minus 1 is equal to 3 times the limit of g of x minus 1. That's it. Okay, that's the same thing. So that means 3 times 5 minus 1, which is 14. Okay, not that hard. Someone might come and say, what about the 2x, Walid? Okay, عادي, it doesn't matter, man. They gave, as long as you have one of the functions, that's okay. That's all you need, okay? Maybe they don't give you 3g of x minus 1, maybe they give you 2x. If they told you, if they told you 2x, and then they said limit of x over here, same thing, you just multiplied by 2, okay? And the answer would then be 10. Question 3. What is the value of limit as x approaches 9? I can't really see. X minus 9 over radical x plus 16 minus 5. So the logical thing when working with limits, the first thing anybody would do is what? They would substitute the value into the function and check the limit, right? That's how we check limits. So easy, right? So yalla, let's start. It approaches 9, so we substitute x as 9. That's it. 9 minus 9 over root 9 plus 16 minus 5. And if you look at that, you get 0 over 25. Radical 25 is 5. 5 minus 5 is 0. And if you do this on your calculator, you're going to get math error. So you got 0 over 0. And obviously, we know that 0 over 0 in math is what we call indeterminate form. It doesn't exist. It's not a number. It's not infinity. 1 over 0. Sorry, 1 over infinity is 0. And infinity over 1 is... Sorry, and 1 over 0 is infinity. So these are the results we know, but we never said 0 over 0 exists. So when you reach 0 over 0, it doesn't mean that the limit is infinite. Okay, so what someone would do here is he's going to go and put 999 because he got 0 over 0 math error on his calculator. See, if you do it, you get 0 over 0, look, 0 divided by 0. You get math error. Someone's going to say, yani infinity. Yalla, let me put 999. He's going to submit, he's going to get the answer wrong. Why? When you get 0 over 0, that means you need to take an extra step. A few years back, 50, 60, 70 years ago, 100 years ago, some French guy called L'Hôpital, okay, his name is L'Hôpital, he came, he saw 0 over 0, and he's like, wait, there's no way I can keep my function at 0 over 0, because when he drew the graph, he saw that, it does approach a number, it doesn't approach infinity, so I need to do something. So over here, L'Hôpital basically said, okay, it's called L'Hôpital's rule, and we're probably going to learn it again, okay, and maybe your teacher doesn't teach you this, but take it from me and it will work every time, okay? L'Hôpital's rule is basically, if a function, okay, if a limit of a function as x approaches a is equal to any function f of x is equal to 0 over 0, then you just derive the numerator and the denominator and solve it again. So if you have a function u over v, okay, any function, let's call it f of x over g of x, right? If the limit of it approaches 0 over 0, if the limit as x approaches any value of this function is 0 over 0, then you have to derive f prime of x over g prime of x. It would have the same limit value. Okay, so in summary, the limit of any function, let's call this whole thing h of x, okay? Or no, let's just say limit of this function as it approaches a, this is our function, right? It's a fraction, any fraction, is also equal to the limit of the same function but derived, f prime of x over g prime of x. Okay, you're gonna see that, oh, you're gonna get 0 over 0 here, so that means you have to apply this rule, derive up and down. Okay, so applying our rule, when you get 0 over 0, what does that mean? That means you take your function, derive the numerator, and derive the denominator. What many people mistake this for is quotient rule. This isn't quotient rule. No, don't do quotient rule. Please don't, okay? L'Hopital is different. You derive the numerator, x minus 9, what's its derivative? Its derivative is what? Just 1, right? Derivative of x is 1, negative 9 is 0. Root x plus 16 minus 5, what's the derivative of it? Minus 5, its derivative is 0, we don't care. Root x plus 16 is the same as saying x plus 16 to the power of half, right? Derive it, take the 1 over 2 down, x over 16, x plus 16, power becomes subtracted by 1, becomes negative 1 over 2, right? And don't forget to multiply by u prime, which in this case is just 1. Remember, you have to multiply by the derivative of the inside, which is just 1, which we don't care. So, the derivative of the numerator is 1. Derivative of the denominator is what? Half x plus 16 to the power of negative 1 over 2. Okay, let's clean this up a bit. You know, you don't even have to clean it up. خلاص. If you got this, just substitute your limit now again. You're going to get 1 over 2 into 9 plus 16 to the power of negative 1 over 2. If you do this on your calculator, you're going to get 10. Okay, let me show you. Over here. 1 over 0.5 into 9 plus 16 to the power of a negative half. You get 10. Okay, so what's the key takeaway over here? When you have a limit, substitute. If you get 0 over 0, that means you have to derive your numerator, write it down, derive your denominator, write it down, and form a new function with the derivative of the numerator over the derivative of the denominator, and then apply your limit once again. Okay, this is called L'Hopital's rule. Okay. Question 4. Below is the graph of a function of f. Which of the following is true? Let me take a look here. Okay, so below is the graph of a function f. Okay, when you see this circle over here, it basically means we change directions. Okay, so this is a piecewise function. It basically tells you it's a piecewise function. So if you kind of think, if I were to write it for you, f of x in this case would be equal to a piecewise function. You'd have this one over here, the line that seems to be 2x, 2x plus 1, okay? And then you have over here 2, right? Y is just 2, yeah? So if you were to write this, and I'm just writing this, you don't need to know this, but I want to write it so you can kind of see what I'm talking about. X less than 1, and then over here, x greater than or equal 1. Okay, so I'm just trying to show you that this is a piecewise function. That's the only reason I wrote this. When you see this in the exam, they tell you what is true. When you have limits and a piecewise function, you need to know that you need to write the limit in terms of plus and minus. So limit, we work with the limit as x approaches any number a. Okay, what if I wrote for you a plus, and what if I wrote for you a minus? Okay, this is very straightforward. In this case, we're talking about 1. Okay, we're talking about as the function approaches 1. We have 1 plus and 1 minus. Okay, what difference does it make? When you're approaching something from the plus, that means you're approaching it from the positive side. So that means you're going from the right side, you're approaching it. Okay, so over here, as I'm approaching 1 from the right side, I would be on this function over here, the horizontal line. Okay, and the y value therefore would be what? 2. So as you approach 1 plus, you're getting 2. As you approach 1 minus, if you take a look at 1 minus, limit as x approaches 1 minus, it means you're approaching it from the negative side, so from the left side. And as you can see over here, it's also what? 2. Okay, nice and easy. Type, as the limit, as x approaches 1, bala plus, bala minus, just 1, you're also going to get what? 2. So someone's going to come and tell me, what's the difference then? Let me give you an example. If you have a function like this, and I went and drew for you the open circle, so you can know that it's a piecewise function. As you can see here, I'm going to put -1 here and 0. Okay, as you can see here, I have a function. It's a piecewise function. It goes like this, and then it switches. It goes like this. Okay. Over here, let's take a look at the limit as x approaches 0. Let's start أول شيء as x approaches 0 minus. As x approaches 0 minus, that means you're going from the negative side. So you're coming down, and what do you get? -1. So it's -1. And then the limit as x approaches 0 plus would be you what? Approaching it from the positive side. And you're going to reach what? 0. طيب, what if I came and I wrote for you limit as x approaches 0? Bella plus, bella minus. In this case, what would you put? I'm going to tell you it does not exist. Okay, why doesn't it exist? For the case, if you have a discontinuous function, okay, take it as a rule. For a discontinuous function, at the point of discontinuity, the limit does not exist. Okay, I want you to know this. Take it as a rule for you. Okay, so over here, the point of discontinuity is x equals 0. So the limit does not exist at x equals 0. Okay, so this does not exist. But does this exist? With a plus? Yes, it exists. Does this exist with a minus? Yes, it exists. But with just 0? No. Okay, you can't. So over here, if it was a discontinuous function, then you may pick this one over here. Okay, but it's continuous as you can see, so it's normal. If it's continuous, then the value for 1 plus, 1 minus, and just 1 will all be the same. I hope they give you another example so I can solve it for you. Consider the function f of x. You have k plus x for x less than -3, and you have 4x squared if x is greater than or equal to -3, where k is a whole number. For what value of k does the limit x approaches -3 exist? Remember, over here, when you have a piecewise function, as you can see, by the way, they put x equals -3. That's the limit they want. And as you can see here, the point of continuity is what? X equals -3. That's the changing point over here, right? So what was the condition I just said? For a limit to exist at the point of continuity, what does it have to be, the function? It has to be continuous, right? It has to be a continuous function. It has to be like this, right? So it has to be continuous. When does it not exist? I told you when it's discontinuous. Okay, so for the limit to exist at the point of continuity, it has to be a continuous function. What does that mean if it's a continuous function? That means the value over here is equal to the value over here, right? Remember, if it's a continuous function, and over here they share the same point at the point of continuity, right? So if they ever tell you for the limit to exist and they give you a piecewise function, you just have to substitute that value of x and equate them. Okay, so let's say we have to say k plus x is equal to 4x squared. Okay, and we said x equals -3, right? So k minus 3 is equal to 4 into -3 all squared. The square is outside, huh? So k is equal to 3 squared is 9 times 4 is 36 plus 3 is 39. Okay, so your answer is 39. Question 6. The definition of a limit that measures limit as x approaches 2 of 3x minus 2 equals 4. What largest value of delta corresponds to, I think this is sigma or I don't know. Okay, no, this isn't sigma. It's one of the Greek letters. It looks like an E. I think it's called epsilon, and that's what's written here. Okay, that doesn't matter. Equals 0.09 in absolute value 3x minus 2 minus 4 less than epsilon whenever. Okay, hold up. Okay, so I low-key didn't know what any of this means, so I had to look it up and read over it a bit. But basically, in math, we have something called the epsilon-delta limit condition. And basically, you guys know how we have a limit, right? Let's say over here. As the limit approaches this x value over here, it approaches this y value. See how it starts to become constant? I'm just giving a certain example. So basically, this rule here, the epsilon-delta limit condition, basically is when mathematicians said, okay, how close do you need to be to this x value, let's say 5? How close do I have to be to 5 to start approaching this limit, this y value? So this is where they came and they said the epsilon delta limit condition. So this says the limit as x approaches a Alhamdulillah. The limit as x approaches a of any function f of x, if it equals any value L, okay, the limit. Okay, then absolute value of x minus a is less than a value delta. This is the simple for delta, such that the absolute value of the function f of x minus L is less than epsilon. Epsilon is like this, kind of like a 3. Okay, so this is the rule. Type, you basically just have to solve this. So they actually gave everything to you. They're just saying epsilon is 0.09. Okay, so you just substitute everything. In the exam, it's gonna come like this. They're gonna give you the value, just substitute it. So 3x minus 2 minus 4 absolute value is less than epsilon, which is given as what? 0.09. Okay, so expanding this, you're gonna get 3x minus 6 less than 0.09. Okay, take the 3 out, you're gonna get 3x minus 2 less than 0.09, right? So you're gonna get absolute value x minus 2 is less than 0.03, because when you divide by 3. Okay, now you can take out the absolute value, because you're only gonna get one solution, in this case, the positive solution. Okay, you're always gonna get only the positive solution, because the rule actually states that you have to be positive. Okay, so you're gonna get x minus 2 less than 0.03. Absolute value x minus 2 is less than 0.03. So what are they asking for? They're asking for delta. So over here, x minus 2 less than delta. What did we get it to be? X minus 2 less than 0.03. So that's literally all you have to do. Okay, just solve this equation, substitute your ellipson value, and you're gonna get a function, an equation. You just solve it. خلاص, you got this, which is exactly what they're asking for. Okay, delta in this case is 0.03. Question 7. I think I should pick up the pace شوي. How long? 22 minutes. Oh, let me pick up, go a bit faster. Okay, what is the value of limit as x approaches 0 for 3 tan 2x over x? Okay, for this limit over here, I had to check the book for it, because there was one of the rules I had to make sure of. Basically, for limits of tan and sine, there's a rule, and the rule is limit, it has to approach 0 of sine a over a equals 1. Okay, and also limit as x approaches 0 of tan a over a is also 1. Okay, it's a rule. So over here, it's kind of like we're doing 3 times the limit of, as x approaches 0, of tan 2a over a. We now introduced a 2, so what does that mean? It's going to become 2, and since you have this times 3, it's going to become times 3. Okay, so tan a over a is just 1, but when you introduce the 2, that means you're multiplying also by 2, and you have this 3 on the side, so it becomes what? 6. So this rule works for tan and sine. Why do you need to know it? Because if you substitute x equals 0, you're going to get 0 over 0, and you can derive tan. You know, tan is just sine over cosine, and derive and use L'Hopital, which is completely fine, but that's going to take you ages. There is a derivative for tangent that you can memorize, but it wasn't taught to you, so there's no reason for you to do it. Okay, so if you see this in the exam, it's so simple. 3 times 2 divided by 1, you get 6. Okay, for sine and tan. It doesn't work on cosine. Okay, don't try on cosine. For cosine, there's also a rule for limit as x approaches 0 of cosine a minus 1 over a, it's 0. Okay, this is also a rule that was in the book. Okay, question 8. What is the value of, what's this? 5 sine x plus sine 10x over 5. Okay, it's same rule. Okay, same rule. Limit as x approaches 0, has to approach 0. Huh? If not, then you substitute the value. Okay, if it's not approaching 0, you take the number and substitute it. But since it's 0, we use the rule. Remember, sine a over a is 1. Okay, so what we're going to do here, we're going to split this up into 2 fractions. 5 sine x over 5x plus sine 10x over 5x, and we're going to treat them separately. Okay, so 5 sine x over 5x. This is sine x over x, right? This, we can write it as 5 over 5 times sine x over x. We know that this cancels to get what? 1. So 5 over 5, which is also 1, times 1, which is 1. So the limit of this is what? 1. Okay, sine 10x over 5x. You have a 1 here. So 1 times 10 divided by 5, which is what? 2. So this is again, we can write it as 10 times the limit of sine x over, you have the 5 over here, x. We know this cancels to get 1. So 10 over 5 is 2. So 1 plus 2, which is 3. Okay? So let me repeat this one more time because I think I kind of confused people with this. Okay? If you want an easy way to do it, just multiply the numbers up, divide them by the numbers down. Okay? That's pretty much it. But in this case, you have to separate it. You must separate it. Okay? Can you actually 50 divided by 5? No, you have to separate it. Okay? If you have a plus, you have to separate it into two fractions. So 5 sine x over 5x plus sine 10x over 5x. Over here, 5 times 1 is 5, divided by 5 is 1. Over here, 1 times 10 is 10, divided by 5 is what? 2. So you get 3. Okay, that's it. Just work with the rule like that. Multiply what's up, divided by what's down. Question 9, 2 sine 10x over tan 4x. Oh, shit. Same rule. Okay, same exact rule. Okay, multiply what's up, divided by what's down. 20 divided by 4, it's 5. Okay, that's it. Okay. Okay, moving on to question 10. What is the value of, over here, x squared minus 256 over root x minus 4 as x approaches 16. So I'm pretty sure if you substitute 16, you're gonna get 0 over 0, right? So let's do 16 squared minus 256 over 4 minus 4, because root 16 is just 4. Yeah, you get 0 over 0. Okay, so we know if you substitute 16, you're gonna get 0 over 0. What do we do when you get 0 over 0? We use L'Hopital, right? So here they use factorization, and the school teaches you factorization, but definitely don't do factorization. I'm not even gonna teach it on this channel because it's bullshit. Okay, you don't use you're never gonna use it. Okay, so over here, what do I want you to do? I want you to use L'Hopital. Okay, if you see 0 over 0. What does L'Hopital say? You derive the numerator. Let's see, x squared minus 256. What's its derivative? 2x. Okay, root x minus 4. Derive it. Okay, what do you get? What's the derivative of root x? It's the same thing as saying x to the power of half, right? You take the half down, half x to the power of negative 1 over 2. And the minus 4 is just 0. Okay, so this is your new fraction, 2x over half x to the negative 1 over 2. Then you substitute your limits once again. 2x, so 2 times 16 over 0.5 into 16 to the power of what? Negative half. You get 256. Okay, once you substitute. So 2 times 16 over half into 16 to the power of negative 1 over 2. Okay, please use this method. Do not use factorization. It's so stupid, especially in these questions. If you use factorization, you're going to get x plus 16, x minus 16 in the numerator. Over here, you're going to get root x minus 4, yeah? Then when you square root this is the same as saying, this is the same as saying root x plus 4 root x minus 4, and then it cancels. It's so stupid. It's so stupid. Okay, so don't use this method. Please use L'Hopital like I explained. Anytime you use 0 over 0, derive your numerator, derive your denominator, form a new equation. Do not use quotient rule as well. Please don't mistake L'Hopital for quotient rule, okay? Question 11. What is the limit as x approaches infinity of 12x squared plus 3x minus 5 over 3x squared plus 2x plus 1? When you're looking at the limit as x approaches infinity, anytime you see when x approaches infinity, you only compare the highest degree terms, okay? Please, only the highest degree terms. We don't care about anything else over here. You always compare the highest degree terms. So we're going to look at 12x squared over 3x squared. Okay, if it's not highest degree, maybe she writes it for you like this and she confuses you guys. Maybe she writes it like this. Someone is, they're going to compare 12x squared and 2x. But that's wrong. Why? Because the highest degree term is 3x squared. It's the highest degree, okay? So you must take a look at the highest power, highest degree, okay? Even maybe sometimes it's arranged differently. Just rearrange it properly, okay? So what are our highest degree terms? 12x squared over 3x squared. Substitute x infinity. Yalla. 12 into infinity squared over 3 into infinity squared. Oh my god, they cancel. You're gonna be left with 12 over 3, which is 4. This follows, by the way, if any of you remember, this is the same way to find the horizontal asymptote. Remember, you plug in x as infinity, and you see what you get. This is the same way. That's the same thing, by the way. Limit as x approaches 4 minus of 9 over x minus 4. Okay, so the first thing you should check here is how do you do this? Hold up. Yeah, if you approach x equals 4, the logical thing to do is just substitute x equals 4. And I saw it. Now, as soon as I saw the function, I saw it's obviously an asymptote. But let's say you're in the exam, you substitute, you see in O, you get 9 over 4 minus 4, which is just the same as 9 over 0. So you get infinity, right? So if they just put x equals 4, without the minus sign, it would just be infinity. But so what's the thing here is, okay, they're saying 4 minus. So this is where you have to say, do I approach positive infinity or do I approach negative infinity? So we know that it approaches an infinity, positive, negative, we don't know. But let's see, how do we check it? So to kind of visualize this, you have your asymptote over here, and you have the function, it either goes up like this, or it goes down like this. So we need to know which one is it. Is it going up to positive infinity or going down to negative infinity? So what do you think you should do? Just substitute a point that's right behind 4. This is the 4. Let's substitute a point that's behind 4. Let's say maybe 3. If you get a negative value, then of course you're going down to negative infinity. If you're getting a positive value, then you're going up to positive infinity, right? So let's substitute 3, okay? 9 over 3 minus 4, and you get a negative 9. You get negative 9. So that means you're what? Where are you? You're in the negatives. So that means you're approaching negative infinity. That's it. So easy. It may be, confusing, but once you get it, it's really nice. Okay, over here, same things, our rule of sine, whatever, I don't know what. What do you do whenever you see sine or tan? Multiply what's up divided by what's down. So 7 over 5. That's pretty much it. Okay. Question 14. Remember, please, it has to approach 0. It has to approach 0. If it doesn't approach 0, you go back and you substitute the number, whatever they gave you. Okay. Question 14. What's the value of limit x minus 5x squared? Okay, see here approaches infinity, right? She gave you a polynomial, rational one. Okay, it approaches infinity. So what will people do again? They said, okay, well, you told me highest degree term, yalla, x and negative x squared. So you take infinity over negative infinity squared. Yalla, infinity with infinity, you cancel. So you're going to have 1 over negative infinity, which is negative infinity. The answer is just 0. And he's going to come here, he's going to put 0. No, I told you, you have to check your highest degree term. Maybe it's not written at the start, maybe it's later. So you have to check what's your highest degree term, negative 5x squared. And over here, what's your highest degree term, negative x squared. So negative 5x squared over negative x squared, obviously your negatives cancel. And then substituting infinity, you're going to get 5 infinity square over infinity square, cancel. You're going to be left with what? 5. So easy. Okay, question 15. Over here, part A, the limit as x approaches 1 over 3 minus, so from the negative side, 2 over 1 minus 3x. Okay, so same thing as the one we solved a bit before. If you substitute 1 over 3, you're going to get your denominator to be 0. Okay, so it will be 2 over 0 when you substitute 1 over 3. Try it. Okay. So you're going to see that it's infinity, and we need to know, is it positive infinity or negative infinity? Why is it infinity? Like I said, because your denominator is 0 at that value. So same thing we did before, just choose a point to the left of 1 over 3. Now, please don't get me wrong. When I say to the left of 1 over 3, I'm only saying this because they're saying 1 over 3 minus. So you're approaching 1 over 3 from the left side. Okay, but when they say like in this example over here 3 plus, you're gonna see that I'm gonna choose a point coming from the right side, so to the right of it. Why? Because they said plus, so I'm looking at it from the right side. So over here in this part A, since they said minus, I'm gonna choose a point before 1 over 3. Now a good idea might be to choose 0, because 0 is close to 1 over 3, and it's right to the left of it. So let's substitute 0. 2 over 1 minus 3 times 0 is just 2. As it is 0, so 2, it's just going to come 2. When you substitute 0, I mean, you're going to get 2. Okay? So since we got a positive value, our infinity will be positive infinity. Okay? Now, taking a look at this one over here, once you substitute, imagine you're seeing the question for the first time. What's the first step? Is to obviously substitute 3, right? So you're going to get 3 over 6 minus 2 into 3, which is 3 over 0. And as you can see here, that's an infinity. So is it going to be positive infinity or is it going to be negative infinity? Like I told you, you need to check one more point to see whether it's positive or negative. So over here, since they're saying 3 plus, are we going to choose 2 or are we going to choose 4? We're going to choose 4 because we're saying 3 plus. So we're looking at it from the right side. So what's to the right of 3? 4. Okay? So substituting 4 now, you're going to get 3 over 6 minus 2 into 4, and you're going to get 3 over negative 2, negative 3 over 2. You're going to get this. Okay? Which is a negative answer. So what does that mean this infinity is going to be? Negative. Okay? Question 16. Consider a function g whose graph is shown below, and they want you to choose the limits. So over here, this is similar to the example I gave you maybe in question 6 or 5 or something like this. It's something like this where it was a piecewise equation, right? Piecewise function. So let's take a look at our choices and take a look. You have the graph right there. It's not going to be anything too hard. So as you approach 0 minus, so that means we're approaching it from the left side, the limit is 0. So let's take a look at 0. When we're approaching it from the left side, as you can see, you're approaching 0, so that's correct. As you're approaching 0 plus over here, so from the right side, you're also approaching 0, as you can see here, right? So that's also correct. As you approach 0, no plus, no minus, just add 0, it's also 0. Which is also correct. As you approach 1 minus, so we're approaching 1 from the left side, right? From the left side, since they said minus, you're also approaching 1. Let's take a look. As you're approaching 1, you're approaching 1. Yes, you are. Okay? Okay? As you're approaching 1 from the plus side, it's 1. Now, this is wrong. Why is it wrong? Let's take a look. As you're approaching 1 from the right side, are you following this curve or are you following this curve? Obviously, you're following the one over here, the one to the right of it. So if you're following the curve on the right, you're not going to be approaching 1, because as you can see here, we're approaching this value here, okay? Since you're approaching it from the right side. So it's going to be wrong to say 1. You have to say what? This is 2, right? So the answer, if it was 2, it would be correct, but it's 1, so it's wrong. Now limit, as x approaches 1, no plus, no minus, just at 1, it's 1. Can we say this? No, we cannot. Why can't we say this? It doesn't exist. Has to be does not exist. Why doesn't it exist? Because at x equals 1, it's a point of discontinuity. So it's not continuous. It's discontinuous. So can you have a limit at the point of discontinuity? Can you? Never, ever, ever. Okay? So over here at x equals 1, it does not exist. But why did it exist at x equals 0? Because it wasn't discontinuing. Hey, it went down to 0. وخلص كفت. It continued. Okay? There's no reason for it to be, it does not exist over here at 0. It's fine, but at 1 it doesn't exist. Okay, yalla, moving on to 17. Okay, you have another piecewise function before 10 and after 10, 4x minus 1 and 4x plus 1, right? So limit as x approaches 10 minus h of x, and limit as x approaches 10 plus. What is it? So let's take a look. As x approaches 10 minus, that means we're going towards 10 from the left side, right? So over here, as you can see, 10 is our point of continuity, right? It's our point of continuity. So let's take a look whether why did I stop talking? Yeah. Let's take a look at the limit when you're approaching 10 minus and 10 plus. When we're approaching 10 minus, that means we're following from the left side. Yeah, so if you have the curve, you're following it from the left side. So which curve am I going to choose? I'm going to choose 4x minus 1 or 4x plus 1? Obviously 4x minus 1, because I'm going before 10. Since they said 10 minus, you're going from the left of 10. Okay, so I'm going to substitute 10 into this one, not this one. I'm going to substitute into this one here, since they said 10 minus, so before 10. Substituting 10, you're going to get 4 times 10 minus 1, which is 39. And you get 39. And then 10 plus, that means I'm approaching 10 from the right side now. So I'm going to be following the curve that's after 10, so the one that's greater than 10. So substituting 10 into this, you're gonna get what? 41, right? Okay, so that's cool. So now they're saying give the value of limit h of x as it approaches 10 if it exists. So now we did 10 plus, we did 10 minus. Now they're saying as it approaches 10, no plus, no minus. If it does not exist, enter 999. The answer is 999 because it does not exist. Why does it not exist? For a limit at the point of continuity to exist, the function must be continuous. And what does it mean when the function is continuous? That means the limit at 10 minus is equal to the limit at 10 plus, as you can see here. This would be a continuous one. But since the limit at 10 minus is at 39, and the limit at 10 plus is at 41, as you can see here, it skipped a step. So at 10, there's no limit that exists. Okay, it doesn't approach anything. Okay, if a limit does not exist, if a limit doesn't approach anything, it doesn't exist. Okay, so for that reason, if you're doing an exam, basically, look at this answer, look at this answer. Are they the same? No, يعني it doesn't exist. خلاص. Don't waste any time. And I'm explaining, I just want you to know why. Okay, so over here, are they the same? No. Does it exist? Also no. So over here for question 18, again, looks very scary, but let's break it down piece by piece. Okay, let's take a look over here. So over here, this 3x plus 3 pi over 4, we can change it to what? 3, if you can see, you can factor out the 3 into x plus pi over 4. Yeah? And you have sine squared over x plus pi over 4 squared. Yeah? So what's this? What's this? Sine squared basically means this all squared. Okay? That's what sine squared means. But we never put it at the end. Okay? So you have this over here. And what was the rule we did? Okay. What was the rule we did? We said, you know, if you have sine, you just multiply what's up divided by what's down, right? So let's take a look over here. This, when you square it, you're going to get sine. 3 squared is 9, right? X plus pi over 4 squared is just x plus pi over 4 squared over x plus pi over 4 squared. So as you can see here, this follows the rule we did earlier. Sine x over x is equal to 1. So this over this is just going to cancel, and we're left with what? 9. Okay, that's it. Question 19. Which of the following is equal to a positive integer? Okay, let's take a look. 4 over 1 over 3. Okay, yeah. So positive integer basically means whole number. Okay, you need to know that. Okay, and you know fractions. We're not looking at fractions. So let's evaluate them one by one and take a look at them, right? So limit sine 4x over 2x as x approaches 0. So they're all approaching 0. So let's just do our rule. 4 times 1 divided by 2, right? Here you do 1 times 4 divided by 2, which is what? 2. Is that an integer? Yes. Here you have 1 times 1 divided by 3, right? Which is 1 over 3. Is that a positive integer? Is that a whole number? No. Here you have 1. Oh. Over here, hatta if it's flipped, you can still apply the rule, okay? Even if it's applied. Remember the sine x over x is equal to 1. Also x over sine x is equal to 1. Okay, same thing. So over here, you can do the same thing. 9 times 1 divided by 3, which is what? 3. Is that a whole number? Yes, it is. Tan 5x over 2. Remember, tan also applies the same rule. So 1 times 5 divided by 2, which is just 5 over 2. Is that a whole number? No, it's a fraction, so we don't want that. X cotan x is... Okay, x cotan x. What is cotan? Cotan is 1 over tan. Right? So therefore, it is the same as x over tan x. Okay? And simply, what are our coefficients? You're going to get 1 over 1, which is just 1. So that's a whole number. Okay, moving on to 20. What is the value as x approaches 3 of x squared minus 9 over 3 minus x? So obviously if you, same thing, yani, if you substitute 3, you're going to get 3 squared minus 9 over 3 minus 3, which is again 0 over 0. So what do we do? What did our friend L'Hopital say? He said you have to derive the numerator and denominator and form a new expression. So what is the numerator? X squared minus 9. Deriving it, what do you get? 2x. 3 minus x, deriving it, what do you get? Negative 1. So that means you're going to get 2x over negative 1 as your new expression. Substituting x is 3 now, you're going to get 2 times 3 over negative 1, which is negative 6. Okay, this is, again, L'Hopital. Okay, this is your new expression. New expression. If you still don't understand L'Hopital, basically you derive your numerator, derive your denominator, and form a new expression from the derivatives. Okay, I'm not using quotient rule. This is not quotient rule. This is called L'Hopital's rule. Okay, question 21. What's the limit as x approaches 1 of 22x plus 3 over 3x plus 2? Same thing. I think if you no, this one, if you substitute عادي, it's fine. 22 times 1 plus 3 over 3 times 1 plus 2. Yeah, that's nice and easy. Nobody should be getting this wrong. It's 5. Okay, that's very easy. Question 22. What's the value of limit x approaches 1, negative 3x plus 24? Again, negative 3 times 1 plus 24 is what? 21. Very easy. These two questions were extremely easy. All you have to do is just substitute, right? Question 23. If x is within alpha from 2, then h of x equals 1 over x minus 1 is within 0.5 from 1. Which of the following might be the value of alpha? Let's take a look. Okay, so for this question, you need to know you're going to see this type of question a lot. There's a specific way you need to do it, okay? When we say h of x, x is within alpha from 2. So x and 2, there's alpha in between it, okay? And then h of x is within 0.5 from 1. So from h of x to 1, there's 0.5 in between. So we're gonna, this is just, they're saying what can alpha be? So over here, I'm gonna give you the general method of solving this, and you're gonna just follow this in the exam. Very stupid, you're never gonna see anything like this when working with math. But anyways, over here, you're gonna start by saying, since h of x and 1 is 0.5 units apart, that means h of x minus 1, the absolute value, will be less than 0.5, right? Since it's somewhere in between 0.5. It's within it, okay? So you're about 0.5 units in between. Okay, so that means h of x minus 1 is less than 0.5. And all you have to do after this is just solve it. Do the math. So 1 over x minus 1, absolute value, less than 0.5. You need to use the absolute value. If not, you will not get the answer, okay? Why are we doing absolute value? Because it's plus minus, and we don't know where. It's within that 0.5 and 1 range. We don't know, okay? So over here, you're gonna get this, right? 1 over x minus 1, absolute value, minus 1, of course, less than 0.5. What do you do here? It's absolute value. So what does that mean? That means you get two solutions, right? One positive, one negative. So we get the positive one, and we also get the negative one. Okay, that's what an absolute value means when working with inequalities. Okay, so you're gonna get this, and simply what do you do? How do you solve this? Just solve it. You're gonna take the minus 1 and add it on both sides, right? So just add the minus 1, right? Minus 1, you take it here, it's gonna come plus 1. And please don't get confused. If you take it here, you should also take it here. So negative 0.5 plus 1 will also be 0.5. This is, sorry, it's gonna come 1.5. Okay, less than, now 1 over x minus 1. Okay, how do you solve this? We need to divide by, you should take the reciprocal, right? 1 over x minus 1, we want to take it up, so we have to flip everything, right? So it's going to become 1 over 0.5. And since you're flipping, this sign should also flip. Okay? So you're going to get that x, it's going to be like this. Now add the 1 on all sides. 1 over 1.5 plus 1, 1 over 0.5, plus 1. So as numbers, so we can kind of think about this. 1 over 0.5 is 2 plus 1, that's 3. So you have 3 greater than x. 1 divided by 1.5 plus 1, you get 1.67. So you're gonna see that x is in between here. Now, someone's gonna go and choose one of these answers, which is definitely wrong. What you need to do now is subtract by 2. Okay, do 2 minus this. Okay, so when you're saying x is within alpha from 2, you need to do 2 minus. Okay, so this is your x value. So we need to know how much alpha is. How do you know what alpha is? You do 2 minus x to find out how far that distance alpha is. Okay, so let's do, yalla, 2 minus 3, which is -1, then 2 minus 1.67, which is 0.33333. Okay, so that means alpha is in between this range here, between 0.33 and -1. So which choice are we going to choose here? This. Okay, any value in between these two numbers. Okay, and they just gave 0.33. Stupid question, definitely. Are you going to see this in math ever to work with it? Never. But will it come in your exam? Maybe. So I can't tell you anything. Okay, if x, again, same thing, x is within alpha from 3, g of x, x squared minus 1 is within 0.2 from 8. Same method. Okay, same method. Yalla, what do? You take your function, you subtract it by your value, right? Absolute value it, and it's less than the distance. Okay, yalla, so x squared minus 9 is less than 0.2. So what does that mean? You get two solutions. Since it's an absolute value, you get one positive, one negative. Okay, like this. Okay, this 9, we're going to add it on both sides. So we're going to get 8.8 less than x squared less than 9.2. So you now have x squared in between these two values. So obviously we're going to get x is less than the root, right? Square root. Over here, the root. Okay, so you now have your x values, very easy. So we need to know how far this is from 3, right? So what will we do? We'll subtract these roots. So 3 minus root 8.8 and 3 minus root 9.2. And let's take a look. Obviously absolute value, right? This should always be absolute value. Okay, since you're looking at distance. Okay, we're looking at how far this is. Okay, so 3 minus root 8.8, you're going to get 0.033, which is this answer over here. And also, we're going to do 3 minus root 9.2. You should get a negative value, but make that value positive since you're working with a distance, okay? Whoa. Okay, I got one answer, but I really need to go, and I can't continue the recording. So I'm just going to post this recording. You figure out how to get the second answer. Good luck, and thank you for watching.